So this is a true story. So on Saturday, after I got here, I took a walk in Victoria Park. It's a beautiful day, walking around, and come upon these three people who are having a conversation, and it's clear they're talking about the end of the world. And so one of them says, now, if you knew there was just one day left, what would you do? Would you kill someone? And so get this, the woman says, not intentionally. But I'd do some crazy stuff. So I'm thinking to myself, okay, now you've got one day left, and negligence is the thing that you're gonna do. Okay. But here's what the next question the guy asked was, would you learn piano? And this is kind of where we are, right? And it's like, all these people in the world, like, this is how they think about music making, is they're gonna get to it when the world ends. Here's another piano I saw yesterday, actually, in the train station in Brighton, and notice that it's padlocked, even though it says "Play Me." Also notice the color scheme, which will prefigure something I'm going to talk about in a second. So I wasn't one of those people who had to wait until the end of the world to learn piano. This is me when I was 2 years old, in front of one of the family's 2 reel-to-reel tape recorders. So my dad was kind of a hi-fi nut, and my older brothers were into electronics, amateur radio, and apparently I took some interest in the tape recorder, which I believe was used to do like interviews with other people in the family. But that's right, we had 2 reel-to-reel tape recorders, and my brothers one time used both of them because there weren't synthesizers or anything like that. They would keep re-recording from one back to the other and slowing the speed down to, actually increasing the speed, to make lower and lower sounds, which then they wanted to play these extremely loud, low-frequency sounds. My dad had some voice of the theater speakers. I don't know if you know that those are like in auditoriums, but they were just in our basement. And they wanted to see if they could play a low-frequency sound and blow the windows out of the house. It didn't work, but. So I heard this yesterday when Jules was talking, this idea of like, you can't let go of stuff. And so these are 2 ideas I'm going to talk about today that I can't let go of. And I came across them early in life and found them pretty useful. And I want to talk about these 2 ideas and how they apply to 3 different things that I've been involved with in my life: making sounds, writing software, and running a company. So that's 6 things, but it won't be organized like multiplication. It's more like you're going to be visiting with your crazy uncle for an hour, and you'll get some combination of software demos and unsolicited life advice. So here's the first idea. And most of us go through life thinking that perception influences behavior, right? So we see something, like we see some candy, and then we go walk over and steal the candy or whatever. But actually, it's reversed. Behavior is the control of perception. And in 1973, this guy, William Powers, wrote a book with this title that was a big influence on me in grad school. Not in 1973, but later. It turns out that this guy, William Powers, had this amazing life, but it was totally outside of academia, and very few people know about his work. But it was hugely influential in a lot of areas, and particularly therapy. So if you're interested in William Powers, you should definitely look at it. It's really interesting. The idea, anyway, is that there's a loop between behavior and perception, or action and perception. And I'll use other words for this. But a good example of why this is important, as opposed to some other ways you can think about going through life, like planning stuff and then doing it later, is thinking about riding a bicycle. So you can't plan your way to riding a bicycle. You can have a destination in mind, but if you followed the plan without having this loop from moment to moment, like you'd fall over almost immediately. And if you're wondering this, yes, this comes from this 1974 bike catalog that was the basis of our first website at Cycling 74. So I don't know that that actually related to this concept of perception action loop, but I just used this. And if you want to see the whole catalog, some guy has actually digitized every bike catalog in the world at bikecatalogs.com or something like that. So, but another way of thinking about this idea of incompleteness, which was in the title, is like when you're riding a bike, it's not clear where you start and end, right? It's like a continuous circle of riding and turning the pedals and stuff like that. So the other idea, which probably will seem more obvious if you know anything about my professional career, is a set of things that you put together and take apart. Except that my interest in this didn't come from software. It came from Lego, and it's probably not uncommon for a lot of people in this room who have similar interests to be interested in these kind of toys. You notice that Lego is kind of an unstated theme or stated theme of pretty much at least a dozen talks here every year. So, so this is a Lego system box from the 1960s when I was growing up. And I just want to point out a few things about Lego that are useful to think about as I keep talking. The first one is that there's a direction of attachment, which is always vertical, right? So this is a compromise, and what I like to think is like the enabling compromise or enabling constraint. The other thing is, I don't know if you're familiar, but there were trees and bushes in Lego, and a lot of the focus of Lego in the 60s was making kind of architectural models or urban scenes, and that's always influenced me and fascinated me. I kind of wanted to be an architect, but I failed the spatial relations test in junior high, and so then I felt like I wasn't supposed to do that. So, but the interesting thing about the trees and bushes is that they're even further compromised, like you can't put anything on them. The second thing, you'll notice the wheels are the one exception to this vertical constraint. And finally, Lego is a system, and one of the things about this system that's important is that it's as easy to take the stuff apart as it is to put it together. So, and the way you put it together is friction fit. So here's another, so all the other ones here, these are things that I actually use in my own life. So this is, do you know, anyone know what this is? This is called shark bite. And it's a way of putting pipes together without welding. And so you can connect PVC or copper pipes, and you just basically jam them into this thing, and they make a watertight seal. And this one's a T connector. And they're basically, when you push the pipe in, you kind of can see there's like little, those dotted lines inside, that's like a bunch of teeth, and they clamp and bite down on the thing. But even more importantly, and the really brilliant thing about shark bite is that there's actually a special tool that can take it apart. And so you get this orange thing, and you just put it on the end, and pushing on this little ring actually releases the jaws and liberates the pipe. So you can reuse it, you can prototype with it if you need. So unbuilding is just as important as building, and we'll come back to that in a second. So here's a picture of someone putting a pipe into the shark bite connector, and notice the black line on the blue pipe there. This is what I didn't know when I tried using shark bite the first time, and I didn't push it in all the way, and then I turned the water back on and flooded my house. Okay, so here's another one. So this is a light fixture called Zettels, and I actually own this. This isn't a picture of my house, but I do own this light fixture because it's like the max of light fixtures. And so basically there's there's a cylinder made out of a kind of mesh in the middle of it, and it's hanging from the ceiling. And then you attach these thin, sort of rigid wires to the cylinder, and then you attach paper. And some of it is pre-printed with love poems in different languages, and some of them are blank, so you can add your own love poems. The designer of this is Ingo Maurer, and he has a bunch of crazy light fixtures that he sells. And it's called Zettel's 5, and the 5 refers to the fact that the paper is A5. So here's a close-up. You can see it just uses these ordinary paper clips that go through the rigid wire. So you can basically put this together any way you want, kind of, as long as you follow the system. But it's not like IKEA furniture, right? You don't put it together once and then it stays together. You can unbuild it and rearrange it anytime you want. Oh, let's see, how do I go back here? So this is, oh yeah, here we go. So this is, I've been getting into building furniture, and this is a design that I made for my son, who commissioned without paying me to build a bookcase. And so the challenge here was, could I build a bookcase that I could take on an airplane, not check the thing, but I mean check it, not like take it on the carry-on. But so essentially, the picture on the left shows you the whole bookcase. And then on the right, you can see I've turned a shelf upside down. So the stuff coming out of the bottom, the little 1x2s, they fit into the gaps between the 1x2s on the sides. So the whole thing goes together with friction fit, just like Lego, and stays together, and you don't need anything else to hold it together. I know what you're thinking, don't quit your day job. But. So the first thing I talked about, making sounds or composing, and I'm done talking about furniture now. So, and I want to think about this perception action loop and apply it to the process of creating music. So this is Joel Chatterby in front of a Moog modular system. I believe that Joel was actually Moog's first big customer, and this totally room-sized system was installed at SUNY Albany. Joel was my teacher in college, and a few weeks into my first year there, his very, very early real-time computer synthesizer changed my life. You'll see a picture of it in a minute. Joel passed away a little over a year ago, but his ideas of interactivity and composition systems are everywhere today. Maybe you just don't know this yet. And in fact, every class with Joel was kind of like the way I'm talking now. It's some combination of total irrelevant stuff, philosophy, demos, and unsolicited life advice. So that was probably a big influence on me too. So the key idea in this notion that Joel called interactive composing was to think about composition systems in terms of two things. And I have actually this program, that little bit of the program that Bobby mentioned, M, on the screen here. And this is one thing here is the variables on one side, and then the controls on the other side. So variables are basically, they can be any property of sound, but it's not like turning the filter cutoff on a plug-in or something like that. These are actually sort of, in Joel's way of thinking, like variables were higher level things that changed lots of stuff about the music in one way. And so I worked on M with two other students of Joel's, Tony Woodhoff and John Offenhartz, and I would demo it for you, but Apple stopped supporting Quick Draw a few years ago, so I can't demo it on this computer, but I have kept it running, and you can download it on the Cycling 74 website if you have an older Mac OS machine. So the arrows are basically the direction of what goes on the right side. The arrows on this for a variable. So if you were to highlight like the velocity range arrow, for example, as you move the conducting hand across the grid in the horizontal direction, it would change the current setting of the variable across the space of these 6 presets. You can think of this velocity range as kind of like a sophisticated way of changing volume of a bunch of voices at the same time. Or you can have transposition of each of the voices represented there in 6 different presets. So this is Joel controlling 2 variables with his very early system. And this was a computer made by a company called New England Digital, which you may have heard of as the manufacturer of the original synclavier. So this computer, which is in that box on the left, is actually the same computer that was in the synclavier, but there was no keyboard interface. He's also using theremins, which were also made by Moog before he made them commercially, to control the sound, but you're not listening to the theremins. They're just controllers. And so in this particular piece, he had 2 variables. And when I first just encountered this idea, I was just like, this is what I want to do for the rest of my life. I thought this was so cool. So one of the variables he called orchestration, and there's sort of a version of this in M, but the idea is that as he moved his hand closer to, say, the theremin on the left, the more instruments would come in the piece. And then the other one, I think, was a kind of similar thing we have in M called note density. So the idea is that like the instruments would get busier. So there's some kind of generative algorithm here. But the idea is that these things you have to listen to for a second. So it's actually this loop of listening to what it sounds like now, deciding what you want to change next, and then changing it. That's part of this idea of intelligent composing. So I did, as Bobby mentioned, I did write a bunch of these programs, but there was something that really bugged me about it, which was every time, people liked the software, but everybody who used it had a feature request. And it was kind of overwhelming. So that brings us to this other idea, and that this idea that I had heard about this software called Max that was being developed at IRCOM, and by this guy Miller Puckett. I had heard about him a long time before that as the first guy who had applied wave shaping to try to make computers do guitar amp distortion. Like this was in like 1981 or something like that. So I knew the guy had to be pretty cool. Anyway, it became clear that Max was could be a building set for making your own interactive composition programs like M. So I could now ignore everyone's feature requests and just say, make it yourself. And because the making itself that you do in Max is also interactive, it's another kind of iterative loop. And so being invited to work on Max was another kind of life-changing moment for me. And I just want to interrupt the talk and have this public service announcement. Like, I guess 2 days ago, someone posted this on Instagram that their Max MSP license plate was stolen. So if you've seen it, the guy will give you a free sequential profit Rev2 synthesizer if you supply information leading to the arrest of the person who stole the beloved Max MSP license plate. I think this is a sign our brand is like trending, but I don't know. So I want to show you an example of an interactive composition variable. This is basically what I just decided to have a variable called marchiness. So on the left, you have the Brigham Young University Marching Band, and then on the right, you have the Stanford Marching Band. And so you can see there's more sort of synchronization and on the left. And this is really kind of a stupid example, but I hope it gives you the idea that you have to listen for a second before you can change it. So I'm going to open Max here, and this is going to be awkward and slow because you have to switch programs. And I'm going to move it over to here. Okay, so I'm not going to explain too much of this thing. I'm just going to play it. And okay, so this is not a very good marching band. But if I move the slider over here, they're all together. But then what's interesting is the space in between where they're okay. Then people start messing up. But notice I have to hear that, where am I, right, before I can kind of move. And then eventually it's just totally uncorrelated. Okay, so that's a little cute example. Hopefully makes some sense. The idea is there's kind of a lot of complexity, but a low dimension of control. So you could imagine just using a theremin for that if you wanted to. Okay, so now I have to figure out where the mouse is. This is the problem with, this is a bad feedback loop. Okay. So now I get Keynote back on this screen somehow. That's the problem here, is like Max hid Keynote on my own screen, so I can't see it. All right. Let's hit play. Sorry about this. Okay. So in Max, we have this idea of building and unbuilding, and that's represented by connecting and disconnecting. And there are three. I just want to point out that you can make the connections, the building, mean a lot of different things. And so over the years, this is just three of many different things that the connections can mean. You have this asynchronous event. So when I click on that 2-on-1, it sends it into that object there. Then the sort of gold line, it represents a data synchronization connection. So essentially the state of the matrix and the patching thing mirror each other. And then below the matrix, you have an audio signal flow. So all of those things are sort of together. And the disconnection, again, is just as important. Let's fast forward a long ways to more recent stuff that I've been working on. So this is more recent version of Max, and it has this new feature called MC, where the connection in that blue snaky line is actually going to represent 100 audio channels. So the idea that I wanted to point out here is that this allowed me to think about interactive composition at the audio channel level and think of this sort of creative space of audio channels that I didn't know existed. And one of the reasons that I didn't know it existed is that, like a lot of you, I was obsessed with optimization. And so the idea that you would put 100 audio channels all doing something at the same time inside your software is like the stupidest idea, because obviously you would never, like, computers aren't fast enough. Well, it turns out they are fast enough to do all this. And I had to kind of get over my obsession with optimization to figure that out. So just a hint. So the idea that I want to show here in this demo is, again, the same concept of low dimension of control, changing like lots of crazy stuff at once. So one thing that I really love is the THX sound that Andy Moore created. And that's a great example. It's just like, if you know the algorithm, it's one slider, and this amazing thing happens. And so a couple of years ago, I tried to figure out some sort of variations on how I could steal that idea. And I'll play a couple of these for you. If I can get my mouse back to, there it is. Okay, so this first one, I'm not going to explain how any of this works, so just listen to it. Should be playing. Yeah, I'll turn it up a little bit. So here's a thing where basically this space is the responsiveness of 60 people to your command. So notice that basically it takes it's 60 audio channels, so they're all delaying how responsive they are to the fact that I just played a different note. And I really love this, like, members of the choir coming in, but slowly over time. And I can actually change the responsiveness here with this number. And if I turn it down, then they change quickly. It almost sounds like melodies, but if I turn it up, you just hear a few people come in, and it's almost imperceptible how quickly they change. Okay, that's one idea that you can use this space for. Here's another one where this thing sounds like reverb, but it isn't. So basically I have the same kind of sample, playing a note. We have a bunch of voices playing that sound. And then I'm going to move this. And it's like they're sort of lagging that makes it sound like reverb. Turn that up a little bit. But it isn't reverb. And then finally, well, let's see if this, so here's really just a complicated one where I can just draw a little thing like this, and so here's the sort of Andy Moore, like going toward everyone playing the same note as I move. Sort of thing. So, oh no. I shouldn't have clicked on that. Okay. Now if I can hit the I'm getting better at this. Where's the mouse? There. Okay, so I want to point something out about how I came up with this, which is that it's innovation through misuse. So everyone, as I said, knows you should never have this many channels of audio if all you're going to do is produce stereo. It's not efficient. but it's actually it's turning away from thinking about problems to thinking about construction that allowed me to see this. If you only worry about other people's problems, you actually get yourself out of that loop between feedback and perception and behavior. You're not trusting your own perception, you're thinking about other people's perception. I'll come back to this in a minute. So now I want to talk about the second thing that I apply loops and kits of stuff that you take apart and put together, which is making software. It applies probably more to your life than the first one, but who knows? We'll see. It's a conference for audio developers, but you might be interested in the topic of making software. So I think that this slide shows up at pretty much everybody's presentation. They're like, well, there's people who are experts, and then there are people who are good at programming. And we want to make the people who are experts better at programming. So what I want to do is actually make the people who are experts at the subject matter bad at the subject matter. No. So my colleague Sam came up with this thing of like the gap should be filled with this thing he called himself neither. And neither is not saying that you don't know anything. It's a way of saying that you don't identify with needing to be on either end of the polarity. Like they're both cool and uncool. And that's what I personally identify with and where I think that interesting software development work might be. I'm going to violate my own rule and talk about a problem for a second. And this is the one that's been bugging us at Cycling 74 and a lot of our customers for a long time. So someone makes something really cool in Max, and then they want to share it with the world, but it's in Max. Max is a wonderful way to make the thing and find it. And I told you it's this great iterative construction set and can do all this cool stuff, but it's stuck because you have to have Max in order to use it. So this person has two options. They can pay someone to port it out of Max, and this has been done on more times than you guys know, or it can be kept to yourself, and this has been done almost all of the time. It's almost like in the latter case, or really the upper case there, that Max is just a flow chart. Now, I have a friend who actually makes software that looks just like Max, but it doesn't do anything. It's just making flow charts, and he's way more successful than I am. So what's the nature of this problem? So basically, Max is this gigantic environment that's like an interpreted language. You have all this code sitting around waiting to be connected together. And it's as if you had your entire Lego set inside your computer, and that takes up a lot of memory, and it's just a big thing to have to deal with. It's a huge project to port this, and I've done this many times over the past 30 years, thanks mostly to Apple. And but really the problem is that Max is a desktop-era architecture. Putting the entire Max environment on other computer platforms like the Arduino or phone or Raspberry Pi or the web or something like that, it's going to be hard, and it's probably not even worth the trouble if all you want to do is just one thing. The final issue is integration. So you may know about this thing called Max for Live. So before Max for Live existed, there was this thing called Pluggo, which is essentially Max as a DAW plugin. So what's so hard about integrating the thing that already works as a DAW plugin into another DAW? Well, that took 3 years. So it's really complicated, and if you're trying to integrate the entire environment, it is more complicated than integrating just the thing that you want to do, I guess is the point. So we have this thing that we have been working on for the last 7 years. Sorry, we're not as fast as Jules. That we call RNBO. And we just released it 2 weeks ago. And it's our solution to this trapped in max problem, which is to basically give you the absolute minimum that you need to implement the thing that you made in max. And I think of this as sort of a static version of max, and I'm not going to go into really the details of what static versus dynamic mean, but you can essentially think of the way that we turn this into all that you need is that we're actually going around and like trying to use your patch in every possible way that it could be used, and then we generate a program that does every possible thing that your patch could do. But we wanted it to feel like max, and so we use this LLVM JIT compilation to generate the code that you're actually listening to while you're in max. So it feels like we're basically creating this simulacrum of the max environment, except that you're always listening to the code that you just patched together. And then finally, we have this thing called targets, which is to try to build workflows out of integration and using different APIs and different target platforms. So basically, you can see this all as the perception action loop and the kit of things you can connect together and disconnect applied to software development. So what is in this code that we give you? So we tried to figure out what changes in anything like this and what stays the same. So the thing that changes all the time is the representation of the thing that you made with your patch that's mixed together with all the rainbow objects and operators. So this is changing as you edit. And then we add this engine code, which is extremely lightweight, and a adapter for the particular API that you're targeting in this particular case. So in some ways, this is like the analogy to SharkBite, the fact that you can build and unbuild, and that's the thing that you want to do quickly. And we lower the time and the risk involved. So you don't solder stuff together, you just connect it and you can take it apart if you need to. The leak-proof seal is the generated code, which presumably is reliable. Well, you know, if it's not, let me know. And then finally, the thing that you have to do kind of once is the cutting the pipe to the specification. So we think of that as the target. That's where you can do extra work to integrate your own code into our code. And we tried to make that as easy as pushing pipe into a thing, but obviously it's harder than that. So I want to give you a quick demo, and this is like the worst possible illustration of the potential of Rainbow, but I sort of wanted to combine it with the MC thing that I showed earlier. And this is, and in the interest of time, I'm not gonna go through this whole process. So I'm gonna act like it's a cooking show. And oh, it just happened to have this thing in the oven that we can enjoy at the table. So, so this thing, which I'm going to move over to here, is, so another thing that we just released is this amazing book about Gen, which is Inside Rainbow and Inside Max by Graham Wakefield and Gregory Taylor. It's just astonishing look at a way of thinking about signal processing and synthesis. Have no time to get into it, but I stole one of the examples, which is this amazing sort of infinite delay that they made, and turned it into, put it in Rainbow. So if I double click on this, oh, it shows up over here, of course. So this is Rainbow, and inside there's this, so looks like MSP, like input and output, and it's just going to this Gen tilde, which you could also have an MSP. And that is this Gen patcher. So that's lifted directly from the examples from their book. And if I play this, you can hear, basically, because it does DC blocking, it just is kind of infinite. And so the question, see, it would last for a long time. So I think it'll just last forever. So the question is, what could I make an MC version of this? So the MC isn't directly supported in RNBO yet. But one of the targets that you can use RNBO for is you can export to max objects. So if I open this RNBO patcher, I click on the export thing, I have this max external export. And if I start this process, which I'm not gonna do, but it essentially goes out to the cloud and it has the whole Max SDK and cloud build system, and it will build your Max external and then send it back to your computer and install it in the place where you want it, and then you can just use it immediately. So let's assume all that happened because it takes a minute, and in the interest of time, here I'm gonna just add one that I've made. I'm gonna say MC GG delay, and I'm gonna make 50 of them. So I say chans 50, and I will insert that into this cable, and I will get rid of this one, which I don't need. And let's listen to what this does. So the cool thing about having 50 channels is that you can set all of them to slightly different things, and there's a thing in MC called deviate. So I'm gonna basically deviate some random millisecond delay around 300 milliseconds, so it'll generate some delays. And now let's turn this guy off, and we'll listen to this guy. So now, why is this? No, this needs to be 1. Not sure why it wasn't 1. Let's try again. Let's play with this a little bit. Okay, so now that I've deviated all of these, check out what this sounds like. It's this absolutely lovely space that just keeps going on forever. And then you can, of course, add more sound to it. Anyway, so it reduces the amount of notes you need to play to have sound. Okay, so let me go back to the presentation, hit the play button. So, what is the nature of code? So we think of if we didn't think about the fact that it could be written by a robot, we could make these observations, right? It's always expensive to make, unless you're really talented. It's risky to change, even if you are talented. It integrates with other programs intimately, like you can do anything you want, and that's really great. And I don't know if you guys can see, but I wrote, it's all customizable. In other words, anything you write, it's always the same. Now, what's the case with generated code? So for us, there's this one-time expense to build this system. And to write the max object that can be generated into this code is a lot harder than writing just the max object that does what you want, right? So you're thinking at one level higher, which is like, how do I describe the thing that I can generate, rather than how do I describe the thing I actually just want to do? But once we've done this, it's basically free to keep changing the software. And this is the big advantage, right? There's no risk in changing at the level of the patch, rather than having to go and change the source code. The same benefit of integration exists because you just get the code. And it's not customizable, otherwise you can't change it anymore, but you can change everything outside of the thing that deals with the patch that you're working on. And then finally, I want to make this observation about how this fits into a larger picture of what making software is about. So you can think of there being 3 phases of making software. The first one is actually having a good idea, and I feel like traditionally this is a strength of something like Max. It lets you come up with something. The second thing is implementing the software. So you could use a tool for prototyping, but it wasn't the same tool that you use for implementing. And this is what we're trying to change with RNBO. And we think that RNBO helps with this to some extent. And the final thing is distributing, and this is someone else's problem. So I'm gonna end it there and not talk about the third part of this, but only to say that the short thing, which would be the short version of what I wanted to talk about, is everything I've talked about, sort of like what's the style of thinking about making sound, what's the style of developing software. Think about creating feedback loops between what you think you should be doing and what you actually are doing, rather than having a decision maker who has nothing to do with actually doing the work involved. That's kind of what I was going to talk about. And the part of it that I think is really important is you think about, sometimes people think, oh, well, the problem we're trying to solve is like artists don't need to be programmers. And I would actually reject that. And I would say, why not? Like, why can't you learn something new? Why can't you transform your life? We assume that who we are as an 18-year-old is the same person that we are as a 60-year-old, and this isn't actually true. The person I was at 18 is not the person that I am now, and I think that's a feature, not a bug. And I mean, there's some things I'd like to be the same as when I was 18, but let's not talk about that. The point is that these tools, these things, these ways of working, they can actually transform who people are, how they think about themselves, and you don't have to say like, oh, I want to stay an artist. Don't tell me any technical details. Actually, learning the technical details could be the medium itself that becomes your art. And similarly, if you're an engineer, all I do is solve other people's problems. Well, what if you created your own problems? Maybe I can say, as the times that I've taught Max in universities, the engineers who picked up Max were way more creative than the musicians. And the trick in doing this was to basically get people to stop judging the outcome. And so transformation in both directions toward neither is entirely possible, and it's entirely exciting. And so with that, I will close and thank you for sitting through the conversation.
Not a question, but I know on the forums it was mentioned that making externals for RNBO I don't think is supported yet, and I want to gauge interest. And I just want to mention I'm very interested and would love to do that as soon as possible.
It doesn't work. I mean, I just showed that it worked.
No, I mean writing a C++ external to use in Rainbow. Is that not possible yet?
Yeah. So so the idea is that could you integrate your own algorithms as objects in the Rainbow system? And
exactly.
Yes, we have preliminary experiments about that, and I'm really excited about making that happen because that is another kind of integration that's really important to support.
Cool. Just want to share my excitement about that as well. Thanks.
Okay, we have another question over here.
You've got 1 day left. What would you do?
I'm sorry, I totally missed that.
You have 1 day left?
Yeah.
What would you do?
I set myself up for this, didn't I? Okay, here's what I thought when I heard that conversation. It's like, I'm gonna have a cold and I'm gonna feel miserable and I'm not gonna feel like doing anything.
Any other questions?
Yeah, I have a question. You mentioned talking about your teaching experience that you experienced that engineers getting involved in Max ended up being more creative than musicians. I'm curious to know, why do you think that is? What is your explanation for that?
Okay, so here's the exercise that I gave a class that consisted of musicians and engineers. I said, make something with Max that makes the ugliest sound you can. And the musicians, they did these super ambitious things that sounded awesome. And the engineers, like, they were so amused with themselves, but they had essentially made patches that sounded like boulez. It was amazing. I was just blown away. Like, they all failed the experiment, but in totally different ways. Like, the sort of going outside your comfort zone, which was the secret agenda of the assignment, like, the musicians couldn't do it. And to me, this is the failure, right? It's that maybe you could look at it as like Max is actually too good because it didn't challenge the musicians enough. Like there's too much music in it or something. I don't know what the problem. But for the engineers, like there wasn't enough engineering to make them comfortable. So they actually did something that that challenged their identity. That's the way I would look at it. So that's what I think about this. You have an identity, and then you're put in a situation where essentially that's useless, and that's actually where innovation and creativity could happen.
Any other questions in the audience? All right. Well, David, thank you so much for joining us.
Thank you.